Good morning, students. We are going to see the extraction of aluminium, a process called Hall-Héroult process, electrochemical extraction of aluminium. Using a method, electrochemical method, we are going to extract aluminium. Now the extraction apparatus or the container consists like this. This is an iron tank. This is an iron tank. Inner lined with carbon. Inside it is lined with carbon. Why carbon? Carbon is a very good conductor of electricity. Also, it is also withstand very high temperature. That is why we are choosing carbon. Now this is rods. Carbon rods are introduced inside. Carbon rods are introduced inside. Now this acts as anode. Anode means positively charged. Current positive charge pass ஆகும். இதில் negative charge pass ஆகும். The negatively charged electrode is called cathode. This is anode and this is cathode. Now inside the tank we are taking these three things. One is alumina, pure alumina from bauxite. From bauxite we are getting alumina. Molten cryolite. Cryolite is nothing but sodium hexafluoroaluminate. Sodium hexafluoroaluminate. We are mixing up with this one. This one we are getting from bauxite, and we are adding calcium chloride. Why calcium chloride? Calcium chloride, the whole thing is in a molten state at a temperature of 1270 Kelvin, nearly 1500 approximately degrees Celsius. அந்த அளவுக்கு very high temperatureல molten stateல இருக்கும். இது மூணுமே. Now the purpose of calcium chloride here is to lower the temperature. Otherwise you need a very high temperature to melt this whole thing. You have to use fuel, you have to use energy, money and so on. So expensive, no? So this calcium chloride helps to lower the temperature. Now this is in a molten state. The electric current is passed. Negative charge flows through this way and positive charge flows through this rod. What is happening at the electrode? Now this is called the electrolyte or electrolytic solution, and here we have pure alumina. This aluminum oxide breaks up into aluminium 3 plus and oxygen 2 minus, breaks up into ion. You must know what is an ion. Suppose there is an atom. Let us take lithium. Atomic number is 3. 1 2 electron and third electron is here. This is lithium 3. Now lithium will become, when one electron goes out, it becomes plus sign, L plus. If calcium loses 2 electron, this is neutral calcium. If it loses 2 electron, it becomes 2 plus. Electron எத்தனை வெளியே போகுதோ அத்தனை plus sign. Suppose if the lost electron plus, வெளியே போன electron திரும்ப உள்ள வந்தது அப்படின்னு சொன்னா, if the electron that goes out has come inside again, then it becomes neutral, not lithium plus, it becomes Li, neutral. Calcium 2 electron, this is called lack of electron. Electron இல்லாத நிலையை தான் 2 plus sign குறிக்குது. Suppose I add 2 electron comes inside, it becomes neutral calcium. If you take chlorine, this is neutral chlorine. One excess electron, அதிகமாக ஒரு electron உள்ள வந்தாக்கா, it becomes Cl minus. This is called ion. This is atom, this is ion. Lithium atom, this is ion. So loss of electron is plus sign, gain of electron is negative sign. Now you see there is aluminium 3 plus. What happens? This goes to cathode. Aluminium goes to cathode. All aluminium goes to cathode. அப்போ அலுமினியம் எல்லாமே இங்கே டேங்க்னோ ஓரப்பகுதிக்கு போகும். So the gain electron becomes neutral aluminum. So aluminum will be deposited at the bottom of the tank. Now oxygen, aluminum oxide breaks up into aluminum oxygen. Oxygen will go here. It will lose electron, give out electron and moves out as oxygen, O2. It goes out like that. Now this is the equation that is taking place, the reaction that is taking place inside. This is a ionic equation. I want to add up this equation, so I am going to add up. So when I add up, I have to cancel on this side and this side, that is common. இந்த பக்கமும் common இருக்கிறதையும் இந்த பக்கம் common இருக்கிறதை அடிச்சிடலாம். Therefore, I am going to multiply this whole thing into 2 because I want to 2 6 are 12. 2 6 are 12. 12 electron, 12 electron this side. Now the rest are all, there is no anything common this side. The arrow mark is the dividing line. This side and this side here, what is common, you strike it off. What is common here and here, you strike it off. The common is electron. Now you add up this one. 2 2s are 4, Al3 plus 6, 2 minus oxygen. 2 2s are 4 aluminum plus 3 O2. So this is the entire equation, final reaction. So you get pure aluminum, molten aluminum here. Now what is happening at anode is that carbon rod, this is carbon. Now oxygen, all the oxygen doesn't go out. Some of the oxygen will react with this carbon, forming carbon monoxide or carbon dioxide. So sometimes carbon dioxide and carbon monoxide goes out. அப்போது நாளடைவில் என்ன ஆகும், இங்கே இருக்கிற கார்பனை ஆக்சிஜனு join ஆகி it becomes carbon dioxide. Gradually the carbon rods corrode, அரிச்சு போயிடும். So you have to replace carbon rod again and again. This whole process is called Hall-Hérold process for the extraction of aluminum. Now we have seen this Hall-Hérold process, right? We have seen just now. I explained to you. Now what this paragraph mean? When we extract metals through this process, like this process, electrochemical process, current pass பண்ணி extract பண்ற method called electrochemical metallurgy. So metals like copper, silver can be extracted. And the equation is given. Now what they are saying here is that this is possible as long as del G is equal to minus NFE. What is this E0? Del G is free energy, F is Faraday constant, and E0 is EMF of the cell. EMF of the cell. Now if the EMF of the cell, you will study in physics, EMF of the cell, it should be positive. Then only del G value will be negative. இது பாசிட்டிவாக இருக்கணும். நெகட்டிவாக இருந்தால் இந்த ரியாக்ஷன் நடக்காது. This will not happen. If it is positive, then plus minus into minus will become minus. Therefore, del G value will be negative. Always when a reaction should happen spontaneously, del G value should be negative. Therefore, if it has to be negative, then this E value should be positive, which is EMF of the cell. So far in the metallurgy, we have been seeing all this concentration of the ore we have seen, extraction of the crude metal we have seen. Now we are going to see refining. Now concentration of the ore, for example, iron oxide or copper oxide. This is the ore. This contains gangue, clay, mud, sand, etc. Removing all this clay, mud, sand is this concentration of the ore. Then you get the metal, pure ore. You get the ore void of clay, mud, sand, other impurities. Now you get the ore. From the ore you extract copper or iron separately, is called extraction. The extracted metal, this is a crude metal, it's called crude metal because still it has got some impurities like silicon, like arsenic impurity, like some other impurities like aluminum. Some few impurities will be there. You want to get only iron, only copper, pure method. That is called a refining process. No, we usually say use refined oil. Why we say refined oil? It is purified oil. So refining means purifying the metal. These are the few methods. First method is distillation method. You can see in the book. This method is employed for low boiling volatile metals like zinc, mercury. In this method, impure metal is heated and evaporated. Now distillation means when there are two, say this one is A and this one is B, two are mixed together. I want to remove, I want to distill, I want to remove this, separate it through this method called distillation. Now one of these temperature will be very low. So when you heat it, that which is very low will evaporate and move through this tube, and water will be circulated around this tube. Water will be flowing, cools down. So the vapor that goes out condenses and comes here. Suppose A evaporates, A will come over here. So this here, for example, distillation, zinc, which is in a vapor state at 1180 Kelvin and mercury 630 Kelvin, which has got low temperature, low melting point. Mercury has got low melting point. So mercury will evaporate. Heat பண்ண 630 degree Kelvin வரும்பொழுது mercury start evaporating, move out here. So it condenses and mercury will be collected over here. Suppose we take A as mercury and B as zinc. Now this B will remain here and A will be separated. This method is called a distillation method. The second method is liquefaction method. This method is employed to remove impurities with a high melting point from the metals having relatively low melting points such as tin, lead, etc. Now you see here the metal is dumped over here in a closed furnace and it is heated. While heating, these impurities will melt at a very low temperature. குறைந்த temperature ஏறும்போது இதெல்லாம் melt ஆகி they will flow down outside. They flow out. In the absence of air, this is carried out. Now what will remain inside is pure metal alone. The metal has got very high temperature and the impurities which has got low temperature, we can use this liquefaction method. The low temperature impurity metals will melt and it will flow down, right? Then what will happen? Only the pure metal will remain inside. This method is called a liquefaction method. You can go through the book after seeing the video, or simultaneously you will be able to understand. The next one is electrolytic refining. Now this electrolytic refining you can always you will come across. Now electrolytic refining means this is an electrolytic cell. These are called electrodes and this is called electrolyte. Now this is anode. Anode வந்து impure rod, impure metal is taken as a anode. அதாவது பாசிட்டிவ் கரண்ட் பாஸ் பண்ணுறதுக்கு impure rod உள்ள ஃபிக்ஸ் பண்ணிடுறோம். This one is pure metal. Say for example silver, impure silver, this is pure silver. It is dipped in a solution. The solution should be salt solution of the metal that I am extracting, that I am refining. Silver nitrate solution is taken. Now the current is passed. When the current is passed, silver from this one will move out into the solution. From the silver nitrate solution, Ag plus will go and deposit on top onto this one. So silver ion will be moving out. More and more silver ion will be moving out and then will get deposited onto this rod, pure silver. Impurities that are present here like aluminum, tin, antimony, whatever be the metal, mud or whatever it impurities, it will just drop down as anode mud. This anode mud. This method is called electrolytic refining. Copper, zinc can be used in this method using electrolytic refining. The next one is zone refining. Zone refining is another interesting method of purifying the metal. Metals like germanium, silicon, gallium can be used. So impure metal is taken as a rod. There is a moving furnace, அதாவது hot furnace, ஒரு என்ன சொல்கிறது, ஒரு அடுப்பு மாதிரி, electric furnace மாதிரி, hot, very hot. So this can be slided from left to right. So this is the rod I am going to purify. This has got certain impurities, whatever may be the impurities like arsenic, phosphorus, sulfur, whatever be the impurities. When the rod is moved from left to right, what will happen? The principle that is applied here is impurities will prefer to be in the molten region. As it moves, it is very hot. This will molten this rod. Suppose germanium, lighta kola kolan urigidum. So as it moves, this side will become cool. First inga hot இருக்கும், move ஆக இங்க cool ஆயிடும். Okay, so this molten region as it moves, the impurities will move along with this one. Impurities எல்லாம் அந்த எந்த பக்கம் molten இருக்குதோ அந்த பக்கம் அப்படி மூவ் ஆயிட்டே இருக்கும். So you go to the end, leave, then come back, then move, then come back, move. Like this, as you move, the impurities will be slided to the corner. So only the pure metal will be left here. We can cut off this one and this is impure one. This is way of purifying called zone refining. This method is called zone refining. This is one of the important questions that is asked. You can study. Next one is wafer phase method. Wafer phase method. In this method, metal is treated with suitable reagent which can form a volatile compound. The volatile compound is decomposed to get pure metal. This vapor phase method. What is this vapor phase method? The principle applied is here is that this is the metal. I want to purify this one. So impurities will be there. Or suitable reagent only the metal, only this metal will combine with this reagent, not the impurities. So it will form a volatile compound. Volatile compound means easily vaporizable, easy evaporate agakudiyadu, vaporizable. So there is two process. One is Mons process where you purify nickel. Nickel is treated with carbon monoxide. At 350 Kelvin, it forms tetra nickel carbonyl. This compound is called nickel carbonyl. Right? You can see in page number 16. Nickel tetracarbonyl. This compound is. This is slightly volatile. Evaporate agudiyadu. 350 Kelvin. But above this, when you reach 460 Kelvin, this volatile compound will decompose, dissociate. Nickel will separate out and carbon monoxide will move out as gas. So you get nickel in this Mons process. Van Oracle process is also vapor phase method. Titanium or zirconium can be purified this method. Titanium is treated with iodine at 550 Kelvin to form tetraiodo-titanium, titanium tetraiodide. Now this tetraiodide compound, which is slightly volatile, easily evaporizable, this compound is passed over a heated tungsten. Tungsten formula is W. Tungsten at 1800 Kelvin. 1800 Kelvin la heat இருக்கக்கூடிய tungsten மேல இந்த compound pass பண்றோம். Now where will you find tungsten? Tungsten you might have seen in the bulb. Bulb எரியும் உள்ள பார்த்தீங்கன்னா சின்ன கம்பி மாதிரி மெலிஸ் கம்பி. There is a small wire will be there. That is called tungsten. That is made up of tungsten. So tungsten, passing of tungsten metal, you get titanium and iodine will evaporate. So what remain in here is only titanium. This method is a purifying method. So we have seen in the purification, distillation, liquefaction method, electrolytic refining, zone refining, and wafer phase method. We have Mons process and Van Oracle process. These are the ways in which we purify the metal. Coming to the last part of this unit, that is application of metals. So their uses, the uses of the metals. Now you can go through the book. It's very easy. I want to leave it to you to study on your own, but still some points you may not be able to understand. Just to explain quickly. Now what are the application of metal? Application of aluminum. Where all aluminum is used? It is a most abundant metal, good conductor of electricity and heat, and resist corrosion. Resist corrosion means அரிப்பு தன்மையை அவ்வளவா ஆகாது, அரிப்பு ஆகாது. So that is why it is very useful. Many heat exchangers, sinks, our day-to-day cooking vessels are made up of aluminum. All that we cooking at home we use, vessels. Those are all made up of aluminum. Some of the metals, some of the utensils. Used in wrappers, aluminum foil, packing food. You would have seen aluminum foils in the train and all, they pack food with aluminum foil. Aluminum is very strong. Alloys with copper, magnesium, silicon, etc. What is an alloy? Mixing of two metal to make it strong. Mixing of two metals into a homogeneous mixture. Copper and aluminum, magnesium and aluminum. This you can mix and make it an alloy. Alloy has got its durable property. So mixing of metals. So used in making aeroplane and other transport. So aeroplane is made up of mainly alloy of aluminum because it is lighter metal, therefore it can fly. And aluminum shows high resistance to corrosion. So also used in chemical reactors, medical equipments, refrigeration units, gas pipelines, etc. சீக்கிரம் aluminum அரிக்காது. It doesn't get corrosion. Aluminum is good electric conductor, helps hence it is electrical cables with steel core for strength. So aluminum wire is used nowadays. What is the use of zinc in galvanization? If you coat zinc on any metal, it will protect from corrosion or rusting. Corrosion means அரிக்கக்கூடியதான் corrosion we say. Rusting is also, you know what is rusting, துருபிடிக்கிறது இல்லையா. Zinc also used in produce die casting in automobiles, electricals, industries, etc. Die casting, making it a very beautiful appearance. Zinc oxide is used in manufacture of many products such as paints, rubber, etc. Let us see the here. In pharmaceutical, plastics, inks, pharmaceuticals means in medicines. We have zinc tablets nowadays, no? They say for corona it is good, they say. Zinc sulfide is used in making luminous paints, fluorescent light, X-ray screens, etc. We have fluorescent paints are there, which reflects light at night, glitters at night, no? Fluorescent, made up of zinc. Brass and alloy zinc is used for water walls and communicating equipments in high resistance to corrosion. Iron, most useful metals and its alloys are very everywhere, including bridge, electrical pylons, bicycle chains, cutting tools, rifle barrels, etc. Iron. For example, steel is an alloy of aluminum. Steel you don't get straight away. Aluminum mixed with carbon forms steel. Steel the bridge eல்லாம் கட்ட முடியும். You cannot construct a bridge with iron, it will break. You need steel. So alloy is very important. Cast iron is used in making pipes, valves, pumps, stoves, etc. Magnet is made up of iron. An important alloy of iron is stainless steel, resistant corrosion. We have our eating plates are made up of stainless steel. It is an alloy of iron. Cutlery, spoon, etc. Surgical instruments, jewelry, all these are all made. Nickel steel is used in making cables, automobiles and aeroplane parts. Chrome steel is used in manufacture of cutting tools and crushing machines. So for example, driller machine is made up of a drilling, pump, drilling, bore well. So it is very hard drilling the rock. So those are made up of a chrome steel. So a mixing of carbon, chromium, iron, all this alloy forms very hard. You cannot use just iron, it will break. Application of copper is the first metal found out by human being in the human history. So alloy bronze resulted in new era, Bronze Age. Copper is used making coins. Copper is used for making coins. It is mixed with gold and other metal. Now the gold chain that we are wearing slightly mixed with copper. Otherwise the gold chain will break easily. Copper and its alloys used for making wires, pipeline, electric parts, etc. This is gold. Gold, one of the expensive and precious metal used in coinage and has been used in standard monetary system. Gold வச்சு தான் இன்னைக்கு economy நிர்ணயிக்கிறாங்க. Okay, so it is very expensive. Used in extensively in jewelry in alloy form with copper. As I said, mixing with copper, we make gold jewels. Gold which are used in watches, artificial limb, cheap jewelry, dental filling, etc. Some of the teeth we have golden teeth, some might have filling gold. So gold is mixed for dental filling of a cavity. சொத்தப்பல் அடைக்கிறதுக்கு we used alloy of gold. Gold nanoparticles are used for making increasing the efficiency of solar cells, also used as a catalyst. Very small minute nano catalyst of gold is used in the solar cells. Now this one you will see, this is an just a general knowledge. Some of you would have visited Delhi and you would have seen iron pillar, Ashoka pillar is made up of iron and it's some other alloy. Still they are trying to find out what it is, because it was erected 1600 years ago. By now it should have got rusted and just broken down, but still it is very strong. They say it is it is coated with a layer of mesavite. What is this mesavite? It is a compound of iron, oxygen and hydrogen which does not rust and gives corrosion resistant. So mesavite na ennandrathu it might be asked in 1 mark question or in a NEET exam, etc. This can be used, right? So this is about the uses of the metals. With this we are completing the unit.